So basically today we have two options. Either we can take up a new domain and try to model it using this strips language, or we can extend the blocks world domain that we have already seen. Which one do you prefer? So yeah, so basically the advantage with blocks world is that it has these negative interactions in goals. So maybe we can stick with it. So let us consider this problem where the initial state is something like this. A, B, and C. We'll take 3 blocks. And the goal is something like this. Okay. So, and what are the state variables that we have? On XY, on table, clear X. And M. And probably holding. There is also a hand. So, can you guys tell me what is the initial state?
On table.
On BA,
On BA,
on CB,
on
table A,
table
and empty,
and empty. So
Clear
it has
C.
to be full.
Is clear C also?
So initial state should have full description of all the elements.
So, one little question.
Yeah.
So, why couldn't we have the on x comma y as a general action for on table x? Like we could write on instead of x.
That is also possible.
Okay.
That is also if basically here we want to differentiate between basically table and another block,
Okay.
and basically types are not allowed in strips. So
Mhm.
we can't say what type y is things like that.
I see.
Yeah.
I see.
I mean, it's actually fine. One could treat table. Only point is if you can't say table block as a block type and table as a table,
Right.
you will end up things like
On a table.
You know, holding table. Putting,
Right.
So, in order to avoid all that, you need to once again put a lot more things in strips.
Mm.
So that's why basically we'll have it separately.
When holding of x is true, will clear of x be also true? Like when
Holding X, no. As per the domain, it's basically a rule that,
clear of x means it should not have any block on it, right?
no, and also it's not being held. That's an understanding. And can somebody tell me what is the goal description?
I mean, same. We should replace A and B in places.
On CA, on
So
A.
goal, the happiness is that it can be a partial state. So you don't need to tell everything. So here, yeah, let us see.
Oh, I see.
Somebody tell? It's basically on AB and on CA. So if you look at it, this is actually enough.
Clear C. That doesn't matter.
Will it?
It's enough.
Right?
Mhm.
And there is only one way to get this, which is that.
Right.
Or you could have it in different ways, right? Like what you're saying that you could have things like on AB you need to say on
Mhm.
CA. Yeah, if we don't want to put negative literals, then yeah, this is the way. Or and you can put more, but doesn't really matter. Right? So this is the goal description. Then next thing is, yeah, let us write heuristics for this state. What is the set difference heuristic for this state? So you might remember, right? What is set difference? How many goal literals are satisfied in this state, or unsatisfied in this state? That is basically the HS.
Two, right?
2. This is not satisfied. This is also not satisfied. So it is 2. So here it becomes important as to what is the goal description. I mean, this is such underestimating heuristic that if you have 2 it says 2, if you have 3 it says 3, so on.
Mhm.
So actually a good heuristic should have said much larger number, right? Then what next? What is H sum? So before this probably we should basically try to draw the planning graph for this problem. So for this state, what is the planning graph? Can you guys work out? Basically, the way planning works is if we have a state, what are all the possible actions? Okay, and put all the effects which this action contributes to, and this entire thing becomes the new level corresponding to states.
Oh, what are the actions here?
Yeah, so that's interesting. We should actually say what are the actions here. So what should be? One is pickup, right? Okay, first let us write down actions and then come to planning graph. It's interesting, right? I mean, you don't even need action model for writing set difference heuristic. So we have pickup and put down, stack and unstack. Okay. Each will have preconditions and effects. Preconditions for pickup are what should be?
And is
Clear
empty.
X.
Hand empty. Clear X. Anything else? That should be fine, right? Hand is empty. Then what will be the effects? Only one is not hand empty. Not clear X.
And holding X.
Holding X. put down X. Put down X, what should be the preconditions?
Holding X.
Holding X.
Do we put not hand empty or holding X implies not hand empty?
So we just need to care about positive literals here in strips. Preconditions will always be only in terms of positive literals. So we should automatically ensure that in all our actions, whenever holding X is true, hand should be empty. So okay, holding X, and effect will be
Hand empty
yeah, hand empty. That's important.
and clear X.
Clear X. Not holding X. This usually we are putting it down on table. So on table X.
But it might be on top of another block.
That is, we do it with stack and unstack actions, not with these actions. This automatically means implicitly on table.
Okay.
Yeah. This is also basically from table. Yeah. So yeah, this is important. Here the precondition is basically on table X, and effect is not on table X. So stack and unstack are the ones we use to modify from top of another block. So stack xy will have preconditions, because we also need to care about the other block, right? We need to make it clear and so on whenever we are taking. Here we don't have information about the other block, so this really can't handle, unstacking from another block. That's why this is just restricted to table, these two, and whenever we are picking up from another block, we need that block's information also. We need to make it clear and so on. So once again, almost same things. First let us do unstack, which is similar to pickup. Then preconditions will be hand empty, clear X. Instead of on table, now we'll have on. That's it. And effects will be not hand empty. Holding X. Which one? Not on XY. Yeah, clear. That's so basically this information we don't have with this pickup action. It's a single literal destination action. stack X4. Bit conditions, effects. So we'll have once again similar to put down where we have holding X. Okay. What else? We want to put it on Y, so clear Y. That's kind of implied here. Table is always clear. So now fx will be hand empty. Okay,
On XY.
on xy. Not holding x.
If it's on something.
Yes, we need to. So earlier our state information is holding x. We can't continue to have that as there. We need to remove it. So we need to have not holding x. What is? Not clear about it. Just put some. So basically, you can see the differences between how what it means to handle with table and block. Table always has enough space, so you never need to say that it's not clear, and you can always assume that it's clear, so it's not there in the preconditions. So yeah. So now that we have this, can we draw the planning graph?
Any big one.
For this state. So planning for drawing the planning graph, basically we need an initial state. These things off. So we'll start with these literals, which is on BA, on CB, on table A, and empty, and clear. Okay. So first is, we'll have no op actions, which will take all these right along. Okay. We'll have all these 5 here. I'll just say this. Then, which of the 4 actions are applicable?
Unstack of C.
We can do unstack C.
No, we can do pick up C. Oh no.
No, pickup is from table.
I get it.
So
Unstack
unstack
C
C
comma B.
from B. Right. What else can we do? Nothing to pick up, nothing to put down, yeah, nothing to stack. So this is the only one.
While constructing the planning graph, like, will we take the proportional variables separately or individually, or will we take it as an intersection? Like we can do unstack of B, right? If we only consider on BA.
No, no. So this is basically, yeah, so we'll actually take individually. But are we satisfying this?
No, actually the clear condition is not satisfied for on BF. Clear
Yeah.
is only C.
Yeah, all which are applicable. So we have unstack CV, which is dependent on and empty, clear, and on X. And empty, clear, and it will give what else?
Holding C.
Not hand empty, holding C,
Not clear.
clear B,
Not clear C.
not clear C,
And not on C.
and not on C. So these two will coexist actually, the not on CB and on CB in the planning graph.
So we are going to calculate the heuristic. We are doing this.
So we want to calculate H sum and H level. So this is the one. Now, does this level satisfy? Does the goal literals exist in this level? Do we have on AB here? No. On CA? No. So we still have to go forward. So constructing a full planning graph involves, reaching steady state where two consecutive levels become same. But we can always optimize it by saying that, these two, whenever the goal literals are found at that level, one can stop. For heuristics purpose. But if you want relaxed plans and so on, yeah, even then we can stop. Okay. So for next level, which actions are applicable?
Put down.
Nothing to pick up. Yeah, we can do put down. So all these will go. Okay. This entire set. Yeah. We'll just. So the entire set of literals will come here also with no op. Just like this. Okay, I'll just say this as previous set. And the new ones are from these actions, which is put down and stack, right? This one. And what does put down do? It gives us hand empty, which is already there, right? Is already there. Clear X, so clear C, which is already there. Okay. And not holding X, so yeah, this we need to write down. So give us not holding C. Okay. What else? And non-table C. table C is not there. So that's it. What about stack? Stack will lead to the previous state, right? So just to be clear, you will actually see that everything is already there. Hand empty will already be there in here itself. And clear C will be there, and on XY will be there, which is on CB, and not holding X will be there, not holding C. Yeah, so not holding C is not explicitly there, but we already put here due to this, so this will come again. Got it. Not clear Y, which is also there. Right? So not clear B actually here. Not clear B is not explicitly there, so we need to write that. Not clear. Okay? Clear? So we just need to add all the things which are not already there. And so, do we have goal state here in any one of these? Not really. These were not added newly, so we need to proceed further. Now what actions are possible? This alternates between, proposition list and action list. Once again, action list. So, which actions are applicable? Yeah. So the nice thing is, one thing to observe is basically whatever actions were previously applicable will continue to be applicable. Yeah, we actually missed these things. So we will continue to have unstack CB. This will also be applicable, right? Because these we already have here. And this will result in, once again, into the same set. Now what about here? We will continue to have all these because, once they are all in the proposition list, they never are taken back. So we'll have, put down what? Yeah, we need to mention this. Put down C, stack C onto B. Yeah. So put down C will continue to be there, stack CB will be there, unstack CB will be there. Probably I should just write this up. Anyway. This will be, what are the new ones? Any questions still now?
So we continue until we get to one of the goals. And right?
Yeah, probably. So we know that in addition to the configuration these are just for our easy purposes. We initially had ABC, and then now we have a situation where we have everything about either this or ABC, right? And the holding ones, all those are here. Holding ones we already taken care of. So the new one which we haven't taken care of is this, right? So which actions are applicable here? So you could pick up C leading to the same old states. You could unstack B, A. Right? What else? There is nothing to put down, there is nothing to stack. Right? That's it. So these are the new ones. So these are old and these are. So the old ones will lead to the same states which we already see. So that will come in as, so in proposition list. All these things which are already there will come. And new ones are from this and this. What will those be? Pickup C, won't really give us anything because the old one had already pickup C. So it will result in all the holding C, clear C, stuff like that, which we already had. What about unstack BA? This will actually give us some new direction. So unstack BA will give us not hand empty, which is already there, not clear, yeah, this is not there, not clear B. Holding B is also not there. Not on BA is also not there. And clear A is also not there. So these are the 4 new ones we got. Right? Now once again action list. Computer will automatically do it for you, but the only interesting case which we need to consider is due to this one and unstack it. So we have B here and A and C lying here. So what are actions are possible? So no picking up and no unstacking. It's about putting down put down B or stack BC or stack BA. Okay, these are the ones. So stack BA won't give us any new ones. If we basically come to, I just continue.